Floating 350 miles above the Earth, the James Webb Space Telescope is returning views of the cosmos that are compelling scientists to re-examine fundamental truths. Its instruments are revealing galaxies that appear to have formed when the universe was in its infancy, black holes expanding at rates that defy known physical laws, and planets surrounded by atmospheres that should not be possible. The discoveries now emerging are fundamentally reshaping the narrative of our universe. We turn our attention first to the era of cosmic dawn, a mere 400 million years after the universe began. In this primordial darkness, scientific models predicted the discovery of small, tentative galaxies, just beginning the arduous process of forming their first stars. What James Webb found instead were colossal, fully formed galactic structures, already swirling with billions of mature stars. These immense cosmic systems possess more mass than our own Milky Way galaxy, yet they came into being when the universe was only about 3% of its present age. The finding is a profound anomaly, comparable to discovering a towering, ancient oak tree in a field that was seeded only the day before. This observation has completely upended our established understanding of how the cosmos evolves. According to all prevailing models, galaxies are expected to grow gradually over billions of years, built up through a slow sequence of countless mergers and cycles of star formation. These ancient giants, however, seem to have had no time for such a deliberate process. Their existence suggests they formed almost instantaneously following the Big Bang, a conclusion that contradicts the foundational timeline astronomers have trusted for generations. Dr. Emma Rodriguez of the Space Telescope Science Institute conveyed the sense of astonishment felt by her team, explaining that they had been searching for the cosmic equivalent of infants, but instead encountered fully grown titans. The galaxies exhibit sophisticated spiral arms, harbour supermassive black holes at their cores, and display chemical compositions that ought to have required eons to accumulate. Yet there they were, completely developed at a time when the universe was just learning how to ignite its earliest atoms. For cosmologists, the implications are deeply unsettling. If galaxies could achieve such enormous mass so rapidly, it suggests that dark matter must behave in a way that is entirely different from our current theories. It could also mean that gravity operated more powerfully in the early universe, or perhaps that we are missing entire chapters in the story of cosmic history. Some researchers are now putting forward the idea that these galaxies may have coalesced around primordial black holes that sprang directly from the Big Bang itself. What makes this revelation even more perplexing is the sheer quantity of these seemingly impossible galaxies. Webb has identified dozens of them distributed across the early cosmos, which indicates that this was not an isolated fluke, but a common pathway for galactic formation. Each new observation compels scientists to re-evaluate the fundamental constants that describe how matter interacts across space and time. These galaxies also radiate light at wavelengths that should not yet be present. They contain an abundance of heavy elements, such as oxygen and carbon, which are forged inside dying stars and require millions of stellar life cycles to produce. However, these galaxies were already mature before such stellar factories could have had sufficient time to operate. It is analogous to discovering finely crafted gold coins within a mine shaft from an era before the invention of mining tools. These findings are compelling astronomers to explore some truly radical possibilities. Perhaps the universe experienced multiple, previously undetected phases of creation. It is conceivable that time itself flowed differently during the cosmic dawn. Or it may be that our entire conception of how gravity sculpts matter on cosmic scales requires a complete and thorough revision. The most disquieting possibility of all is that these galaxies were created through physical processes that are no longer active in our universe. The fundamental forces that shaped the cosmos in its infancy may have been profoundly different from the physics we observe around us today. But if these massive galaxies could form with impossible speed, what does that imply about the supermassive black holes that reside at their centers? Within the Crab Nebula, located 6,500 light-years from our world, stars are being born in an environment where no stars should be able to form. The conventional process of star formation is understood to require a very specific set of conditions. It needs vast, dense clouds of gas and dust, frigid temperatures near -400 degrees Fahrenheit, and millions of years for gravity to gently compress the material until nuclear fusion can begin. This sequence has long been considered delicate, predictable, and well documented. That was the consensus, at least, until Webb began to witness stars emerging in settings that should be instantly fatal to them. These unconventional stars are materializing inside active supernova remnants, where temperatures soar to millions of degrees and intense radiation ought to disintegrate any budding stellar nursery. The scene is as counterintuitive as watching flowers flourish inside the chamber of a blast furnace. Moreover, powerful stellar winds from nearby massive stars should disperse any gathering gas clouds long before they could collapse to form new suns. And yet, Webb's images clearly capture bright protostars taking shape within these turbulent cosmic landscapes. What is even more strange is that these impossible stars are forming far more rapidly than any known mechanism can explain. While typical star birth unfolds over millions of years, these stellar anomalies seem to complete their formation in just a few thousand years. They appear to skip entire developmental phases of the standard model of stellar evolution, transitioning from a gas cloud to a burning star, as if following some unknown, accelerated cosmic blueprint. The images from Webb reveal something that seems to violate every established rule of astrophysics. Inside the Orion Nebula, for instance, young stars are forming within gravitational fields that should tear them to pieces. The immense tidal forces exerted by neighboring massive stars create conditions of extreme stress, akin to being stretched on a cosmic scale. Despite this, these stellar infants not only endure but seem to thrive amid the chaos. Dr. Michael Chen at Harvard has been investigating these anomalous formations. His research team made the startling discovery that some of these impossible stars contain heavy elements that simply should not be present in such young celestial objects. The creation of these elements necessitates multiple generations of stars living and dying, a history these newly formed stars could not possibly have. The mystery only deepens upon examination of their energy output. These stars shine with a brightness and heat that far exceeds what their mass should permit. A star with the mass of our own Sun, for example, is observed generating the energy of a star 50 times more massive. They appear to be fueled by fusion processes that our current physics textbooks assert are impossible for stars of such low mass. What astronomers find most alarming, however, is the rate at which these impossible stars are being discovered. Webb is detecting new ones forming every few months, which suggests that whatever mechanism is responsible for their creation is currently accelerating. This phenomenon also seems to be spreading into other regions of space that were previously thought to be stable. Some scientists have proposed that these stars are forming through interactions with dark matter, which we cannot directly observe. An alternative theory suggests they could represent an entirely new phase of stellar evolution, one that has been triggered by cosmic conditions that exist only in our present epoch. One of the most unconventional theories for star formation ventures into the realm of quantum mechanics, suggesting that some stars may emerge through tunneling effects that permit matter to circumvent the standard requirements of gravitational collapse. What makes this idea compelling is that these stellar anomalies do not seem to be random occurrences, but instead appear to follow deep patterns that currently elude our understanding. They are observed gathering in specific cosmic regions and may even be coordinating their formation across immense distances through the subtle language of gravitational waves, creating synchronized stellar births. If stars themselves can deviate from the fundamental principles of their creation, it prompts a profound question about the planets that orbit them. Some 50 light-years away, a world circles a star named TOI 715, and its very existence presents a deep paradox. The Webb telescope has analyzed this planet's atmosphere, and the data it returned challenges our core assumptions about planetary chemistry. This distant world has an atmosphere with oxygen levels higher than those found on Earth, nitrogen in concentrations that should be chemically unstable, and water vapor that remains suspended in atmospheric layers that ought to collapse under their own immense weight. The discovery is as confounding as witnessing a fish swimming effortlessly through the open air. According to all established models of planetary formation, this world should be nothing more than a lifeless, barren rock. It orbits its parent star at a distance considered far too close to permit liquid water, yet it somehow sustains vast and complex cloud systems that stretch over entire continents. The atmospheric pressure at its surface is 3 times greater than Earth's, But instead of creating a crushing, toxic environment, this density gives rise to weather patterns of remarkable stability, almost as if they were arranged to support life. The truly unsettling finding, however, emerged when Webb detected the chemical signatures of industrial pollutants within the atmosphere. These are compounds that, on our own planet, are known to originate exclusively from manufacturing processes, and they appear in concentrations that would suggest large-scale industrial activity. Yet this world is presumed to host no intelligent life, possess no technology, and have no known natural mechanism for producing such complex chemicals. Dr. Sarah Kim, from the Exoplanet Research Institute, has been meticulously tracking these strange atmospheres across a growing list of worlds. Her research indicates that at least 30% of all rocky exoplanets may harbour atmospheric compositions that defy the known laws of chemistry. Elements are found in combinations that should be impossible to sustain, held together by mysterious energy sources that have no known scientific explanation. The most striking example of this phenomenon is a planet designated HD 40, 37 grams. Its atmosphere contains pure metallic hydrogen, but in a gaseous form, at temperatures where it should instantly condense into a liquid state. This gaseous metal organizes itself into intricate, lattice-like structures that resemble crystalline formations, creating atmospheric layers that behave like solid sheets while remaining entirely gaseous. An even stranger characteristic is the presence of atmospheric tides. While Earth's atmosphere is relatively uniform, these exoplanets exhibit enormous masses of gas that surge across the planetary surface, much like ocean waves. Entire layers of the atmosphere migrate from the day side to the night side, following patterns that align with precise mathematical sequences rather than the expected chaos of weather. Webb has also detected powerful atmospheric lightning storms that can rage for years at a time, generating electrical discharges so immense they are visible across interstellar space. These storms give rise to plasma formations that hold stable, geometric shapes, suggesting the presence of some unknown organizing principle that governs the behavior of planetary atmospheres. The chemical signatures found within these worlds tell a story that should not be possible. Heavy elements, which can only be forged in the hearts of stars through nucleosynthesis, are found in a pristine state, appearing more as if they were deliberately manufactured than formed through natural cosmic events. The isotope ratios within these elements follow patterns that do not correspond to any known stellar or planetary formation model. Perhaps most disturbing of all is the discovery of atmospheric synchronization. Webb has observed planets, separated by dozens of light-years, undergoing identical atmospheric changes at precisely the same time. When the composition of one planet's atmosphere shifts, others follow suit within hours, despite the vast distances that make any known form of communication impossible. Some of these atmospheres even contain complex molecular structures that seem to be self-replicating, growing in complexity over time without any identifiable energy source. If these are indeed some form of atmospheric organisms, they appear to be actively terraforming their host planets through processes that operate on timescales far faster than biological evolution. The implications of these findings are staggering. It suggests that either our entire understanding of planetary chemistry is fundamentally flawed, or these worlds are being actively engineered by an intelligence we are currently unable to detect. Yet these atmospheric mysteries seem almost minor when compared to what Webb uncovered about the black holes that power these distant systems. In the heart of the galaxy GN11, located 11 billion light-years from Earth, there resides a black hole that should not exist. This immense gravitational object holds the mass of 40 million suns, yet it formed when the universe was merely 400 million years old. According to Einstein's equations, the growth of black holes is constrained by a specific maximum rate of consumption known as the Eddington limit. Even if this black hole had been feeding continuously at that absolute theoretical maximum, it would have required several billion years to achieve its current size. It somehow managed to grow to these impossible proportions in only a tiny fraction of the time that physics would seem to allow. This discovery has forced astronomers to confront an uncomfortable possibility. Either our comprehension of black hole physics is incomplete, or these ancient giants were formed by mechanisms that are no longer active in the modern universe. It is akin to finding a fully grown mountain that appeared to have risen from a pebble to its peak in the course of a single day. Webb has since identified dozens of these impossibly large black holes scattered throughout the early cosmos. Each one of them violates the fundamental speed limits that are thought to govern how matter can accrete into a gravitational well. They appear to have bypassed the normal, gradual rules of growth, somehow consuming entire star systems in single cosmic events that should have overwhelmed them. Dr. James Wright of the Black Hole Research Consortium has referred to these objects as cosmic rule breakers. His calculations indicate that for these black holes to have reached their observed masses in the time available, they would have needed to consume matter at rates 100 times faster than the Eddington limit permits. At such extreme feeding rates, the intense radiation produced should have forcefully pushed away any incoming material, making further growth impossible. The puzzle only deepens when examining how these black holes interact with the galaxies they inhabit. Instead of slowly influencing star formation over millions of years, they seem to shape the entire structure of their host galaxies almost instantaneously. Galaxies that should require billions of years to develop their signature spiral shapes are observed fully formed around these impossible black holes. Even more unsettling is the finding that these ancient objects emit energy signatures that do not align with any known physical processes. They produce gravitational waves that inexplicably arrive before the light from the same cosmic events, a phenomenon that hints they may somehow be capable of bending causality itself. In their presence, time appears to flow at a different rate, with stars completing their orbits faster than relativistic models can account for. The Webb telescope, however, has uncovered something even more peculiar. It seems these supermassive black holes engage in some form of communication across the vastness of cosmic space. When one alters its level of activity, others react in a time frame that suggests information is being transferred faster than the speed of light. They appear to function as a coordinated network, synchronizing their behavior through mechanisms that challenge our very understanding of space-time. Perhaps the most unsettling finding comes from an analysis of their X-ray emissions. These black holes are generating energy patterns that do not correspond to any known astrophysical process. The radiation signatures imply they are drawing power from a source beyond the standard conversion of matter into energy, as described by Einstein's famous equation. It is as if they are tapping into fundamental forces of nature that we have yet to identify. One theory proposes that these black holes are primordial, having formed directly from the Big Bang itself as dense gravitational concentrations that bypass the usual path of stellar evolution. Another hypothesis suggests they may serve as gateways to parallel dimensions, where entirely different physical laws are in effect. For cosmologists, the implications of this are staggering. If black holes can operate outside the fundamental limits of physics, our entire conception of gravity, space-time, and causality could be nothing more than an approximation of a far more complex reality. But the mysteries of black holes are merely the prelude to Webb's broader challenge to establish science. Examining the light spectrum from the distant galaxy Max 149 John, the telescope found something that effectively rewrites the chemical history of the universe. This ancient galaxy, which formed when the cosmos was only 500 million years old, is rich with heavy elements like gold, platinum, and uranium in concentrations that should have taken another 10 billion years to form. These elements are forged only in the explosive deaths of massive stars or the collisions of neutron stars. Yet, they are found here in remarkable abundance, at a time when the universe had barely begun to create its first stars. This discovery fundamentally contradicts our knowledge of stellar nucleosynthesis. The accumulation of heavy elements requires many generations of stars being born, living, and dying. Each successive stellar generation forges progressively heavier elements, slowly enriching the cosmic inventory over billions of years. Finding these materials in such a young galaxy is comparable to discovering a complete collection of Shakespeare's works inside a prehistoric cave. Dr. Lisa Martinez from the Cosmic Chemistry Lab has been charting these elemental anomalies across dozens of early galaxies. Her surveys indicate that nearly half of the most ancient galaxies observed exhibit these impossible elemental abundances. Elements that should only be created through neutron star mergers are appearing in galaxies far too young to have hosted such events. The isotope ratios present an even stranger narrative. On Earth, elements have predictable isotopic signatures that reveal their formation processes. These ancient galaxies, however, contain isotopes in proportions that do not align with any known nuclear process. It suggests some elements were somehow manufactured rather than having formed through natural stellar evolution. Webb also detected something particularly disturbing within the galaxy cluster, a Bell 2744. Ancient galaxies in this region contain technetium, an element so unstable it decays completely within millions of years. And yet, these galaxies are billions of years old. The presence of technetium points to either its continuous production through an unknown process or a mechanism that violates the laws of radioactive decay. Even more mysterious is the appearance of rare Earth elements in concentrations thousands of times higher than theoretical models predict. These elements are typically formed in trace amounts through very complex stellar processes. Early galaxies, however, seem to be mass-producing them through a method that leaves no other observational trace. The elemental patterns suggest that these ancient galaxies had access to nuclear processes that are no longer active in our current universe. Some spectra show evidence of super-heavy elements, with atomic numbers beyond anything on our periodic table. These theoretical elements are supposed to be impossibly unstable, yet they seem to remain coherent over cosmic timescales. The most unsettling discovery of all is the organized distribution of these elements. Instead of the random scattering expected from chaotic stellar events, the elements appear to follow distinct mathematical patterns. Certain galaxies display elemental abundances that match precise geometric ratios, as if assembled from a cosmic recipe. Webb has detected elemental signatures that indicate matter was being transmuted at the atomic level, using processes that bypass standard nuclear physics. Elements appear to transform from one type into another without generating the expected byproducts of nuclear reactions. The implications challenge our very definition of matter itself. Either the early universe operated under a different set of physical laws that allowed for rapid element synthesis, or these galaxies were seeded with heavy elements through a process that science has not yet discovered. Some researchers have proposed that these elements arrived through interactions with parallel dimensions where different nuclear physics might apply. Others suggest the early universe contained exotic states of matter that could rapidly synthesize heavy elements through quantum tunneling effect. But these elemental mysteries pale in comparison to Webb's discovery of light itself behaving in an impossible way. From 13 billion light-years away, in the deepest reaches the telescope can penetrate, ancient light is carrying messages that challenge the fundamental nature of reality. These photons began their journey when the universe was only 100 million years old, during the enigmatic epoch when the first stars are believed to have ignited. But the light signatures Webb is detecting tell a story that fits no theoretical model of early stellar evolution. The spectra contain absorption lines corresponding to molecular structures that are far too complex to have existed in the primordial universe. According to the theory of Big Bang nucleosynthesis, the early universe consisted only of hydrogen, helium, and trace amounts of lithium. The first stars should have been massive, simple giants, burning pure hydrogen through straightforward nuclear fusion. Their light ought to reflect this chemical simplicity. Instead, Webb is detecting the spectral fingerprints of complex organic molecules, heavy metals, and compounds that would require sophisticated chemistry to form. Dr. Robert Kim from the Early Universe Research Center has stated that these observations are akin to cosmic archaeology, revealing artifacts that should not be possible. The light signatures from these first stars point toward the existence of planetary systems with complex chemical cycles, a level of sophistication unexpected in a universe thought to be young and simple. What is particularly unsettling involves the polarization patterns within this ancient light. The orientation of a light wave's vibration tells a story about its source and its journey through space. Yet these primordial photons exhibit polarization that suggests they traveled through structures that simply should not be present in the cosmic void. The ancient starlight holds an even deeper puzzle. In place of the violent, chaotic signatures anticipated from primitive stellar furnaces, these first stars appear to have burned with an incredible degree of stability and precision. The patterns of their energy output suggest they were somehow regulated, enabling them to sustain a consistent luminosity for millions of years, without the fluctuations that define every known stellar object. Webb has detected spectral lines, indicating these ancient stars forged elements in proportions that are a perfect match for what is needed to create Earth-like planets. Instead of the random elemental assortment expected from early stellar nucleosynthesis, these stars seem to have produced specific chemical inventories, as if they were following a prescribed formula. This light also contains information about the cosmic environment during the universe's earliest moments. Photons that were absorbed and re-emitted by primordial gas clouds carry molecular signatures, suggesting that complex organic chemistry was already active when the cosmos was presumed to be sterile and lifeless. Most mysteriously, the ancient starlight displays periodic modulations that repeat with mathematical exactness. These variations in brightness follow patterns which imply that the first stars were somehow synchronized across immense cosmic distances, pulsing in harmonious rhythms that spanned millions of light years. Some spectral features seem to encode information in binary patterns that are reminiscent of digital communication. The light variations follow sequences that do not correspond to any known astrophysical process, but they do possess characteristics similar to engineered signals. It is as if these very first stars were broadcasting messages throughout the cosmos. The implications of this are staggering. Either the first stars were formed by processes completely unlike anything we observe today, or the universe began with a level of organization and complexity that our models simply cannot accommodate. The ancient light signatures raise the possibility that intelligence may have arisen in the universe far earlier than was ever thought possible, maybe even before the first galaxies had fully taken shape. But these stellar mysteries seem minor when compared to what Webb has revealed about galactic collisions that defy explanation. Located 4 billion light-years from Earth, two massive galaxies are colliding in a way that appears to violate every law of gravitational physics. When galaxies merge, the process is expected to take hundreds of millions of years as gravitational forces slowly draw the stellar systems together. Astronomers can predict precisely how these cosmic crashes should play out based on the laws of Newton and Einstein's relativity. Webb, however, has captured images of galactic collisions that are occurring at an impossible speed, with results that do not match any computer simulation. The antennae galaxies offer the most shocking illustration of this. These two spiral systems ought to be in the initial phases of a billion-year merger. Instead, Webb shows them finishing gravitational interactions that should require eons, achieving in mere millions of years what physics indicates should take 1,000 times longer. Dr. Patricia Chen from the Galactic Dynamics Institute has been investigating these impossible mergers. Her team found that the colliding galaxies are somehow exchanging mass and energy through mechanisms that seem to operate faster than light-speed communication would permit. When one galaxy loses stellar material, the other gains the exact same amount almost instantaneously. Despite being separated by a distance that light needs thousands of years to cross, the mechanics of the collision defy fundamental physics. Rather than the chaotic stellar scattering predicted by gravitational models, these galaxies merge with an almost choreographed precision. Stars from the different systems arrange themselves into new configurations that display a mathematical symmetry that is impossible to reach through random gravitational interactions. Webb detected something even more unusual during these cosmic events. The colliding galaxies are generating energy signatures that have no explanation in conventional astrophysics. Gravitational waves from the mergers arrive with frequencies that suggest the galaxies are accessing additional spatial dimensions during their collision. The stellar debris from these mergers does not act in accordance with the conservation of momentum. Material ejected from the collision zones follows paths that curve back on themselves, creating loops and spirals that violate the basic laws of motion. Some stellar streams even seem to flow backward through time, with light from the debris arriving before the collision event that created it. Most disturbing of all are the synchronized collision events. Webb has observed multiple pairs of galaxies in different regions of space that are undergoing identical merger processes at the same time. Galaxies separated by billions of light-years are exhibiting matching collision patterns within time frames that point to coordinated behavior. The collisions also give rise to new types of cosmic structures that should be gravitationally impossible. Hybrid galaxies emerge from these mergers with mass distributions that form stable configurations, defying orbital mechanics. These new galactic forms hold shapes that would require a constant input of energy to prevent gravitational collapse. Yet they display no indication of the energy sources necessary for such stability. Some collision sites are generating phenomena that appear to bend space-time in localized regions. Light passing through these areas follows paths that curve more sharply than Einstein's field equations predict, which suggests the presence of exotic matter states or modifications to gravity itself. The merger processes also appear to selectively preserve certain stellar systems while destroying others, following patterns that suggest intelligent design. Planets with specific characteristics are surviving the cosmic chaos, while others are obliterated, as if the collisions are adhering to predetermined criteria for what is to be preserved. While improbable mergers between galaxies suggest that large-scale cosmic structures might operate by rules we do not yet comprehend, perhaps involving forces beyond our current physics, these puzzles are now overshadowed by Webb's detection of solitary worlds journeying through the cosmic void. These planets drift alone in the darkness between stars, separated by trillions of miles from the closest sun, wandering the galaxy like celestial ghosts. Their very existence is a deep enigma. The conventional view was that these rogue worlds were ejected from their nascent systems during chaotic periods of planetary formation, destined to freeze in the cold of interstellar space. Without a star to warm them, they should be nothing more than lifeless balls of ice, with surface temperatures barely rising above absolute zero. Yet, the Webb telescope has revealed something extraordinary about these orphaned worlds. They appear to be generating their own heat and light. The planet designated WISE 830 plus 2837 offers the most compelling case. This world, floating by itself 40 light-years from Earth, radiates an amount of energy comparable to a small star, despite having no source of nuclear fusion. Its surface temperature climbs to nearly 1,000 degrees Fahrenheit, which is warm enough to sustain oceans of liquid water that should have turned to solid ice billions of years ago. Dr. Alexandra Rodriguez of the Planetary Sciences Division has been studying these unusual wanderers. Her surveys indicate that rogue planets are substantially more numerous than previously imagined, with billions of them scattered across our galaxy. Even more perplexing is her finding that many exhibit signs of dynamic weather systems, atmospheric circulation, and even phenomena that resemble seasonal changes, all without a sun to power such cycles. On these rogue worlds, Webb identified atmospheric compositions that defy easy explanation. Instead of the frozen, chemically inactive atmospheres one would expect on planets in a perpetual winter, these worlds sustain intricate chemical cycles that demand a continuous input of energy. Some even show levels of oxygen that would suggest active photosynthesis, a process thought to be impossible without sunlight. The most curious discovery comes from measurements of their magnetic fields. These isolated planets produce magnetic fields more powerful than Earth's, even though they lack the molten metal cores believed to generate planetary magnetism through dynamo effects. The patterns in these magnetic fields suggest the worlds are somehow drawing upon energy sources for which there is no known physical explanation. Stranger still is the synchronized behavior that has been observed among multiple rogue planets. Webb has monitored clusters of these orphaned worlds that preserve exact distances from one another as they travel in formation through space. They appear to move as if linked by unseen forces, holding geometric arrangements that point to coordinated movement rather than random gravitational influence. Some of these rogue planets emit radio signals whose characteristics are reminiscent of artificial transmissions. The signals exhibit modulation patterns that do not correspond to any known natural radio source, yet they show features consistent with engineered communication systems. These cosmic broadcasts seem to be aimed at particular regions of space, with a timing that implies deliberate messaging. The Webb telescope has also detected rogue planets with surface features that look as though they have been artificially altered. Geometric patterns, visible through infrared imaging, hint at large-scale engineering projects that cover entire continents. These features display a mathematical precision that is difficult to achieve through natural geological activity. The thermal signatures of these wandering worlds point to internal heat sources that function through unknown mechanisms. Rather than showing the gradual cooling anticipated for planets that have lost their stellar energy source, these worlds hold steady temperatures, suggesting they have access to exotic methods of energy generation. Most mysteriously, certain rogue planets seem to be actively navigating towards specific destinations instead of drifting aimlessly through space. Their trajectories follow paths that would necessitate constant course adjustments, implying they are either under intelligent guidance or are following some form of cosmic navigational system. These findings intimate that planetary systems can not only exist, but also flourish without stars, governed by principles that lie beyond conventional astrophysics. But these wandering planets are merely the beginning of Webb's revelations about water found in unlikely places. Deep within the Orion Nebula, 1,500 light-years from our world, Webb has detected immense clouds of water vapor floating in areas where every molecule should have been obliterated eons ago. This stellar nursery experiences temperatures of thousands of degrees Fahrenheit and is saturated with intense ultraviolet radiation, which ought to disintegrate water molecules within hours. Nevertheless, Webb observes stable water clouds that stretch across light-years of space, preserving their molecular integrity in an environment more severe than the surface of the Sun. This discovery seems to violate fundamental chemistry, as water molecules are composed of 2 hydrogen atoms bonded to 1 oxygen atom by chemical bonds that are relatively fragile. In the extreme conditions of star-forming regions, these bonds should break apart almost instantly, leaving only individual atoms to be dispersed by stellar winds. To find intact water molecules here is as counterintuitive as finding a pristine snowflake inside a blast furnace. Dr. Maria Santos from the Astrochemistry Research Institute has been charting these unexpected water deposits. Her spectroscopic analysis shows water concentrations that surpass what should be feasible even under the most favorable conditions. Some areas contain water vapor densities that approach those of Earth's tropical rainforests, all existing in the vacuum of space where such water should not be able to survive. The signatures from this water reveal isotopic ratios that do not align with any known formation process. Typical water is created through predictable nuclear reactions within stars or chemical reactions in cool interstellar clouds. However, these anomalous water clouds contain hydrogen and oxygen isotopes in proportions that point to their formation through exotic nuclear processes which follow entirely different physical laws. Webb also uncovered something even more peculiar about the behavior of this water in space. Rather than dispersing randomly throughout the cosmic medium as physics would predict, the water vapor gathers into organized structures that maintain their coherent shapes for millions of years. These aqueous formations create patterns that bear a resemblance to biological cell structures, hinting at some unrecognized organizing principle at play. Furthermore, the water clouds exhibit dynamic behavior that currently lacks a clear explanation. Vast currents of water drift and circulate across expanses measuring dozens of light-years, forming a kind of cosmic weather system that functions entirely without the influence of planets or atmospheres. These interstellar water cycles appear to be remarkably self-sufficient, perpetually recycling their molecular building blocks through processes that demand no outside energy. Perhaps the most perplexing observation is that these reservoirs of water seem to be expanding. New clouds are materializing in areas of space once thought to be arid, taking shape through a mechanism that assembles complex molecules from basic atomic elements at a rate that defies our current understanding of chemistry. The phenomenon has a quality more akin to biological replication than to conventional chemical synthesis. Some of the water signatures detected by Webb possess characteristics that indicate the presence of dissolved organic compounds suspended in the vacuum of space thousands of light-years from any known planet. Inexplicably, these clouds harbor molecular structures that are normally found in association with living organisms. Furthermore, this water demonstrates properties that seem to contradict the laws of thermodynamics. Webb's spectroscopic analysis has found evidence of water in regions so hot that any liquid should vaporize instantly. Yet here, it exists in an exotic state that simultaneously shares characteristics of a gas, a liquid, and a solid. These unusual phases of water remain stable in environments where their very existence should be impossible. The discovery presents a fundamental challenge to our comprehension of chemistry itself. It suggests either that water can persist in conditions far more extreme than our laboratory physics would permit, or that these cosmic clouds are formed by processes that operate beyond the known rules of molecular science. This finding hints that the fundamental ingredients for life could be much more widespread and durable throughout the cosmos than we have ever presumed. Yet even these mysteries of cosmic water seem less profound when compared to Webb's observations of time itself, which appears to behave in unexpected ways near massive cosmic structures. Near the supermassive black hole at the heart of galaxy M87, Located 54 million light-years from us, Webb is witnessing time stretch and compress to a degree that makes the predictions of Einstein seem modest. General relativity tells us that massive objects warp space-time, causing time to pass more slowly in their immediate vicinity, an effect that is typically subtle and requires highly precise atomic clocks for detection. Webb, however, is observing time dilation so pronounced that it is directly visible in the orbits of stars, which accelerate and decelerate in patterns that defy our models of relativistic physics. For the stars orbiting nearest to the black hole, the observed temporal effects are hundreds of times greater than what Einstein's equations calculate. The dilation of time around these stars is so severe that their orbital periods visibly alter over the course of months, not the millennia that standard relativity would suggest. It is as if we are observing a great cosmic clock, its hands erratically speeding up and slowing down, governed by principles that lie beyond our current physical laws. Dr. Stephen Park of the Relativistic Astrophysics Center has been investigating these temporal anomalies, and his measurements indicate that the space surrounding massive objects has zones where time flows at multiple rates at once. In some areas, time appears to accelerate, while in adjacent areas it decelerates, establishing temporal gradients that should not be able to exist. Webb has uncovered another, even more unsettling aspect of these effects. Rather than changing along the smooth curves predicted by Einstein's field equations, time dilation around these objects occurs in distinct jumps and abrupt shifts. This suggests that time may function in quantum steps instead of as a continuous flow, hinting at temporal mechanics that involve principles beyond classical relativity. The observations also point to stellar systems, where extreme time dilation appears to scramble the relationship between cause and effect. Light from stellar explosions has been detected before the arrival of the gravitational waves that should have preceded them, creating event sequences that seem to defy causality. In the orbits of some stars, effects have been observed months or even years before their apparent causes. What is perhaps most mysterious is Webb's observation of synchronized temporal effects between objects separated by immense distances. A change in time dilation around one massive object is mirrored by a simultaneous, similar change around another object thousands of light-years away. These coordinated variations imply that space-time may not be a collection of independent gravitational wells, but rather a deeply interconnected network. These temporal effects also appear to affect matter in ways that extend beyond simple gravitational acceleration. Within regions of extreme time dilation, atoms exhibit energy signatures that suggest their internal components are aging at different rates. The spectra of some stars indicate that their nuclear processes are running either faster or slower than what would be predicted by atomic clocks, given the observed time dilation. Webb has even detected areas in space where time seems to be flowing backward in relation to its surroundings. Light coming from these temporal anomaly zones has red shifts that grow over time instead of staying constant, which could mean that photons are aging in reverse as they travel through this warped space-time. These temporal phenomena give rise to observational paradoxes, calling into question our most fundamental assumptions about the nature of time itself. Certain stellar systems seem to exist in several temporal states at once, with spectroscopic signatures showing conditions from their past, present, and future all at the same moment. Such extreme phenomena suggest our universe is governed by temporal mechanics far more intricate than the comparatively simple model of space-time curvature proposed by Einstein. The implication is that time may not be a fundamental dimension of reality, but rather an emergent property arising from deeper, underlying physical structures. And yet, even these mysteries of time are themselves overshadowed by Webb's findings on dark matter, which refuses to conform to our expectations. Across the Coma Cluster, some 300 million light-years from Earth, this invisible substance appears to be acting as if it has its own agency. According to theory, dark matter should be a simple material that interacts only through gravity, forming vast, smooth halos around galaxies and their clusters. Computer simulations have long predicted how this unseen material ought to be distributed across the universe, providing the structural framework for normal matter to form stars and galaxies. However, Webb's observations using gravitational lensing show dark matter behaving in ways that challenge every existing theoretical model. Rather than creating the anticipated smooth distributions, it seems to be arranging itself into intricate geometric patterns that stretch for millions of light years. The architecture of this invisible material reveals patterns that look more like biological neural networks than the random clusters anticipated by models of gravitational collapse. Dr. Jennifer Walsh, with the Dark Matter Research Consortium, has been charting these anomalous structures. Her work using gravitational lensing surveys shows that concentrations of dark matter shift and reorganize on a timescale of millions of years, which is far more rapid than gravity alone would permit. This unseen substance appears to react to shifts in the distribution of ordinary matter, almost as if it possessed some kind of awareness. The Webb telescope has detected an even more peculiar aspect of dark matter's behavior. Rather than staying gravitationally tethered to single galaxies as theories suggest, it seems to flow between galactic systems. This movement occurs in organized streams that form connections between distant clusters. These dark matter highways are capable of transporting unseen mass across immense cosmic distances, using mechanisms that function apart from standard gravitational pull. The observations have uncovered dark matter concentrations that hold precise geometric relationships with one another over vast stretches of space. The dark matter halos surrounding separate galaxies exhibit synchronized fluctuations, which implies a form of communication or coordination between these invisible structures separated by millions of light years. Perhaps the most unsettling discovery is that dark matter seems to foresee the future behavior of ordinary matter. Gravitational lensing maps have shown dark matter concentrations accumulating in regions where galaxy clusters are destined to emerge millions of years in the future. The invisible material appears to know where normal matter will eventually gather, long before that matter even starts to move in that direction. The Webb telescope has also witnessed dark matter interactions that break the core assumption that this enigmatic substance responds only to gravity. Within the collision zones where galaxy clusters meet, dark matter displays behavioral patterns, suggesting it is subject to forces beyond simple gravitational attraction and repulsion. The signatures from the lensing data point to dark matter having an internal structure far more complex than what would arise from simple particle interactions. Certain concentrations of dark matter exhibit layered density profiles that hold stable configurations, an impossibility under dynamics governed purely by gravity. More mysteriously still, the distributions of dark matter around different galaxies show correlations that suggest they share information or are based on common organizing principles. Galaxies with no possible causal link between them possess dark matter halos with identical structural features, as if they were constructed from the same cosmic design. Dark matter also appears to shape the formation of normal matter structures in ways that extend beyond its role as a simple gravitational scaffold. The rates of star formation and the evolutionary paths of galaxies correlate with dark matter configurations, suggesting an active involvement rather than a passive gravitational influence. These observations present a direct challenge to the fundamental belief that dark matter is composed of simple, weakly interacting particles. Its behavior suggests it could be a complex system with emergent properties that lie beyond the scope of current particle physics. This discovery implies that the invisible universe is governed by rules that are fundamentally different from those of the visible cosmos we can observe. Yet the mysteries of dark matter seem to pale in comparison to Webb's discovery of stellar explosions that are forcing a rewrite of physics textbooks. Inside the galaxy, NGC 2770, located 88 million light-years from our planet, stars are exploding in ways that defy all known laws of stellar evolution. When a massive star depletes its fuel, it should follow a predictable course toward its end. The star's core collapses and then rebounds in a supernova, leaving behind a neutron star or a black hole. This sequence has been witnessed thousands of times and has aligned perfectly with theoretical models until Webb began to find supernovas that detonate multiple times. These stars appear to resurrect themselves after a seeming death, producing energy outputs that surpass what should be possible for their mass. The supernova known as SN 2023 ABC offers the most stunning case. This stellar blast was first seen in January, growing to its maximum brightness over several weeks before it faded as anticipated. However, in March, the very same star erupted again, this time with even greater force. By December, it had exploded a total of 5 separate times, with each subsequent event being more powerful than the one before it. Dr. Rachel Kim from the Stellar Death Research Institute notes that these repeating events are like cosmic phoenixes that simply refuse to remain gone. Her spectroscopic analysis reveals that every explosion ejects material equivalent to the mass of several suns, yet the star somehow regenerates enough matter to fuel the next blast. This process violates the conservation of mass and energy on a scale that challenges fundamental physics. Webb uncovered something even more unsettling about these impossible supernovas. Instead of the chaotic explosive patterns one would expect from a collapsing stellar core, these events display precisely timed detonations that adhere to mathematical sequences. Some stars explode in patterns that correspond to Fibonacci numbers, sequences of prime numbers, or geometric progressions. The mechanics of these explosions defy basic nuclear physics. A typical supernova is the result of a collapsing iron core that can no longer withstand its own gravity. But these repeating supernovas have spectroscopic signatures showing they explode while they are still fusing lighter elements, such as helium and carbon. They seem to circumvent the normal sequence of stellar evolution completely. Most mysteriously, certain supernovas seem to detonate before the conditions that should trigger them are even present. Webb has observed stellar explosions taking place while the progenitor stars still show signs of stable nuclear fusion. The explosions appear to anticipate the star's eventual demise by millions of years. Their energy outputs shatter the theoretical limits for stellar detonations. Some of these supernovas unleash energy equivalent to the total conversion of matter into energy, as described by Einstein's famous equation. Yet they accomplish this while expelling more mass than the original star ever contained. It appears they are creating matter and energy from some unknown source. Webb has also detected supernova remnants with impossible chemical makeups. Instead of the expected blend of heavy elements forged in the explosion, some remnants contain pure isotopes of elements that should not exist in such high concentrations. The products of these explosions point to nuclear processes that operate under a different set of physical laws. Stranger still are the observations of coordinated supernova events. An intriguing picture emerges from observations of stars in different galaxies, separated by millions of light years, that end their lives in unison, displaying perfectly matched energy profiles and spectroscopic details. This synchronized demise of stars hints at a form of connection between stellar systems across the vast emptiness of space. In some cases, the shock waves from these supernovas seem to propagate faster than the speed of light, arriving at distant points before the light from the explosion itself. These superluminal blast waves appear to carry information about the event's nature ahead of the visible blast. These observations point to the conclusion that the death of a star is a process far more intricate than a simple gravitational collapse and thermonuclear detonation. Yet, even these stellar mysteries are eclipsed by what the Webb telescope has found concerning the very fabric of reality. Deep within the cosmic microwave background radiation, the residual glow from the Big Bang, Webb has uncovered patterns suggesting that our universe may not be the only one. The CMB is expected to display almost uniform temperature variations, the very seeds that grew into galaxies 13.8 billion years ago. While these minute fluctuations have been mapped with incredible precision and align with models of a single, expanding cosmos, Webb's greater sensitivity has unveiled something more. It has found additional patterns embedded in this background radiation that cannot be accounted for by any single universe theory. These anomalous features manifest as geometric structures, repeating with mathematical regularity across immense stretches of the sky. The characteristics of these structures suggest they could be imprints or shadows cast from adjacent dimensional planes that have some influence on our own observable universe. Dr. Amanda Chen at the Multidimensional Physics Laboratory has been deeply investigating these seemingly impossible patterns. Her team's research has revealed that the geometric signatures align with theoretical models of interactions between parallel dimensions, each governed by its own unique physical constants. The patterns imply that our universe resides within a much larger multidimensional fabric, a place where different realities can intersect. What is even more unsettling is that Webb has shown these dimensional signatures are not static relics from the universe's birth. Instead, they are active, evolving structures that change over cosmic timescales. Certain regions exhibit geometric shifts that correlate with significant cosmic events in our own universe, pointing to a real-time interplay between these parallel dimensional spaces. The cosmic background radiation also seems to hold information that looks like encoded messages from other versions of our universe. A statistical analysis of the temperature fluctuations has uncovered binary patterns whose features are more consistent with artificial communication than with natural cosmic phenomena. Perhaps the most stunning discovery of all is the presence of temporal loops within these cosmic background patterns. Some of the geometric structures appear to contain information about future cosmic occurrences. This suggests that parallel dimensions might operate under different rules of time, where the past, present, and future can all exist at once. Webb has also identified specific areas in space where the conventional three-dimensional geometry seems to completely break down. Light passing through these zones follows trajectories that can only be explained by invoking additional spatial dimensions. Photons seem to find shortcuts through a higher dimensional space, which allows them to arrive at a destination before they technically departed. These dimensional interactions also appear to exert an influence on the matter and energy within our universe. Galaxies situated near regions with strong parallel dimension signatures exhibit structural characteristics that cannot be explained by standard gravitational evolution. These cosmic objects look as if they are being shaped by forces originating from outside our own dimensional space. Some of the signatures from these parallel dimensions show patterns that mirror the large-scale structure of our own universe, but with different physical constants. These imprints of alternate realities suggest the existence of other versions of our cosmos, where stars, galaxies, and planets came into being under a different set of physical laws. This discovery implies that what we perceive as the entirety of the universe might just be one layer in a far more complex, multidimensional reality. Our physical laws and constants could be merely local properties that change across different dimensional spaces within a grander cosmic architecture. These parallel dimension signatures also hint that consciousness and intelligence might not be restricted to our universe alone, but could exist across multiple dimensional layers, which could potentially explain some of the coordinated behaviors seen in cosmic events. The implications of this work challenge our most fundamental assumptions about the nature of existence itself. In the most profound survey images ever taken, Webb has found galaxies that seem to have existed before the universe itself began. According to Big Bang cosmology, our universe is 13.8 billion years old, and nothing can be older, as time itself started with the cosmic expansion. Every atom, particle, and quantum of energy is thought to have emerged from that singular moment when space and time came into being. However, Webb's most distant observations are revealing fully formed galactic structures with estimated ages greater than 15 billion years. These impossibly ancient galaxies show features that would require billions of years of stellar evolution to form. They contain population 3 stars, which should have burned out long before the Big Bang, alongside supermassive black holes that would have needed eons to accumulate their observed mass. Discovering these cosmic elders is like finding the pyramids of Giza buried deep within Precambrian rock formations. Dr. Marcus Rodriguez from the Temporal Cosmology Institute has been examining these chronological paradoxes. The analysis from his team shows that these ancient structures give no indication of taking part in the cosmic expansion. While every other object in the cosmos is moving away from us because of this expansion, these primordial galaxies hold fixed positions in space, as if they exist entirely outside the expanding framework of space-time. The spectroscopic data reveals even more bizarre temporal signatures. The light from these impossible galaxies displays redshifts that alter over time, but not in a way that would be expected from an expanding universe. Instead, the light appears to be aging in reverse, becoming progressively bluer as Webb gathers more data over a period of months. Gravitational lensing effects detected around these ancient structures also suggest they have mass distributions that predate the formation of dark matter halos. These particular galaxies seem to influence the fabric of space-time using methods that appear distinct from the gravitational interactions that have sculpted every other known structure in the cosmos. What is especially compelling is the revelation that these pre-Big Bang formations exhibit what look like signs of technological intervention. Through infrared imaging, we can discern geometric arrangements and energy signatures more akin to engineered systems than to objects formed by natural astronomical phenomena. The implication is that these ancient galaxies were deliberately modified by intelligent entities that existed prior to the beginning of our own universe. These impossible galaxies also broadcast transmissions in frequency bands that have no correlation with any understood astrophysical process. The patterns of modulation within these signals are consistent with communication technologies, suggesting civilizations were active in these structures billions of years before the Big Bang initiated the space and time we currently occupy. A deeper chemical analysis shows that these primordial galaxies are composed of isotopes whose decay signatures point to their formation under a different regime of physical laws. The nuclear reactions that forged their elements apparently followed constants and principles that diverge from the physics governing our universe today. Some of these ancient formations also seem to be interconnected by networks of exotic matter, creating conduits that stretch across distances larger than our entire observable universe. These remarkable connections suggest that the pre-Big Bang cosmos might have functioned not as a collection of separate objects, but as a single, integrated system. The consequences of this discovery could fundamentally alter our perception of cosmic origins. If it is possible for structures to persist for longer than the universe itself, then the Big Bang might not have been the absolute beginning of all things, but merely a phase change between different states of a much older and more intricate reality. Yet even these pre-universal structures seem less astonishing when compared to Webb's discovery of planets forming in stellar environments that should be completely prohibitive. A magnetar located 15,000 light-years from us is surrounded by forming worlds, despite possessing magnetic fields a quadrillion times more powerful than Earth's. Planets are taking shape in a region where conditions should instantly vaporize any form of solid matter. Magnetars are considered the most extreme stellar remnants in the universe. As collapsed neutron stars, they produce magnetic fields of such immense power that they can warp the very atoms of matter, elongating electron clouds into needle-like formations and making conventional chemistry impossible. The surface of a magnetar can reach 18 million degrees Fahrenheit, while its magnetic field is potent enough to rip apart any approaching material at the molecular level. Despite this, Webb has registered the definitive signatures of planetary formation in orbit around these cosmic behemoths. The planetary system observed around the magnetar SGR 1806-20 seems to violate every known tenet of planet formation theory. Rocky worlds are somehow able to keep their solid surfaces while moving through magnetic fields that ought to reduce them to a stream of subatomic particles. These impossible planets have atmospheric spectra that show the presence of stable weather systems, all while enduring conditions more extreme than the core of a nuclear reactor. Dr. Elena Vasquez of the Extreme Planetary Science Division has been investigating these cosmic anomalies. Her work indicates that the planets are holding stable orbits, defying the combined gravitational and magnetic forces that should have either consumed them or ejected them into interstellar space in a matter of hours. Their orbital dynamics appear to be governed by principles that go beyond standard celestial mechanics. Webb uncovered something about these magnetar planets that was even more surprising. Rather than being annihilated by the intense radiation and magnetic forces, these worlds seem to be sustained by them. The surfaces of the planets emit their own light, which suggests the extreme stellar environment is somehow being harnessed as an energy source for complex geological activity. The composition of their atmospheres reveals chemical processes that should not be possible under such duress. Elements that normally need gentle conditions to create complex molecules are somehow engaged in elaborate chemical cycles, all within magnetic fields strong enough to levitate mountains. A few of these worlds even show oxygen levels that could point to active biological processes operating in an environment that would sterilize any form of life known to us. Perhaps most mysteriously, the orbital periods of these magnetar planets are synchronized, forming mathematical ratios too exact to be the product of random gravitational settling. The worlds seem to perform a choreographed ballet around their impossible star, hinting at artificial orbital engineering rather than natural celestial dynamics. The surfaces of these planets also exhibit features that look more like constructed megastructures than natural landforms. Geometric patterns that cover entire continents display a mathematical precision that is impossible to explain through normal planetary processes. These surface alterations appear to be designed to collect and redirect the magnetar's immense energy output. Webb has even witnessed transfers of material between the magnetar and its planets that seem to violate fundamental physics. Matter is seen flowing from the neutron star toward the planetary surfaces in focused streams that somehow retain their structure across millions of miles of destructive radiation and magnetic fields. Furthermore, the planets emit radio signals whose characteristics do not match any known natural source. The frequency modulations in these transmissions are reminiscent of technological communication systems, raising the possibility that these impossible worlds could host intelligent life adapted to extreme magnetic conditions. Some of the magnetar planets also exhibit temporal anomalies, where features on their surfaces age at different rates based on their exposure to the magnetic field. Areas subjected to stronger magnetic forces show geological processes that unfold millions of times faster than normal planetary timescales. This finding suggests that planet formation and evolution might occur under conditions far more violent than ever imagined, perhaps enabled by exotic physics that only manifests in the most extreme corners of the cosmos. But the puzzle of impossible planets gives way to an even more fundamental mystery, observed by Webb: light that appears to be traveling through dimensions we cannot perceive. In the vast expanse separating Earth from the Andromeda galaxy, some 2.5 million light-years distant, photons are taking routes through space that should not exist. Light is expected to travel in straight lines through the vacuum, requiring exactly 2.5 million years to cross the distance to Andromeda. While Einstein's theory of relativity does account for gravitational lensing, where massive objects can bend light, the fundamental speed limit of light itself is understood to be constant. Yet, an astonishing discovery by Webb complicates this picture. Light from Andromeda is reaching us thousands of years prematurely. It seems to have somehow bypassed enormous sections of three-dimensional space. While the spectroscopic signatures of these photons are identical to those traveling the normal route, their arrival times show they covered the same distance in substantially less time. These shortcut photons appear to have utilized higher dimensional pathways, enabling faster-than-light travel without contradicting relativity in our familiar space. Research from Dr. Sarah Kim at the Multi-Dimensional Optics Laboratory has been focused on these anomalous light paths. Her interferometry measurements have revealed that the phase relationships of these early photons are consistent with passage through folded spacetime geometries. These complex geometries can only be explained mathematically by introducing additional spatial dimensions. Webb uncovered something even more unusual about these dimensional shortcuts. The rapidly traveling light is imprinted with extra information that normal photons cannot carry. These enhanced photons hold data about cosmic structures they should never have met on their journey, which suggests they passed through regions of space outside our observable universe. The shortcut light also exhibits polarization patterns that indicate an interaction with types of matter unknown in ordinary three-dimensional space. Certain photons display quantum entanglement signatures, implying they retain a simultaneous connection with their origin points, even as they travel through higher dimensional routes. What is most perplexing is that the dimensional shortcut phenomenon seems to be intensifying over time. More and more photons are finding these higher dimensional pathways, and the time savings are becoming more pronounced with each observation period. The universe appears to be evolving new transportation systems that function beyond the limits of conventional spacetime. Webb has even seen light that appears to arrive before it was radiated from its distant source. These temporally displaced photons suggest that higher dimensional routes might offer a view into past events, opening windows into cosmic history that should be forbidden by known physics. The enhanced dimensional photons also carry encoded information that looks more like an artificial data transmission than a natural light signature. Statistical analysis has found binary patterns embedded within the light's quantum properties, with characteristics that align with technological communication across a higher dimensional medium. Some shortcut photons exhibit energy traits suggesting they gained power during their journey. These energized photons arrive with more energy than they started with, indicating they tapped into energy sources exclusive to higher dimensional regions. The dimensional light paths also seem to be selectively available, Only photons with specific quantum properties can find the shortcuts, while others must travel through normal three-dimensional space, a selection criteria suggesting that higher dimensional access requires precise quantum states. This discovery implies that our three-dimensional universe exists inside a larger multi-dimensional framework, where information and energy can move through channels invisible to conventional detection. The phenomenon hints that consciousness and intelligence could naturally function across multiple dimensions, which might explain some of the synchronized cosmic behaviors observed in the universe. But the mysteries of dimensional light seem minor when compared to Webb's discovery of energy sources that have no basis in known physics. Far out in the galactic halo, 40,000 light-years from any star, the telescope has detected energy emissions that violate the fundamental law of conservation. These enigmatic power sources are generating the energy output of entire stellar systems, yet they exist in regions of space with no visible matter, black holes, neutron stars, or any other objects capable of such immense releases. The emissions seem to materialize from completely empty space, creating something from nothing in a direct challenge to thermodynamics. The energy signatures themselves are unlike any known physical process. Instead of the broad spectrum emissions one would expect from matter conversion, nuclear fusion, or gravitational collapse, these sources produce finely tuned frequencies that suggest technological origin rather than natural astrophysical events. At the Exotic Energy Research Center, Dr. Michael Chen has been mapping these impossible power sources across our galaxy. His surveys have uncovered hundreds of these mysterious energy emissions, scattered through areas where no energy production should be occurring. Each source maintains a consistent level of output, which points to controlled generation instead of chaotic natural processes. Webb has detected something even more unsettling about these energy sources. They appear to be growing in strength over time, with power outputs that are increasing along mathematical progressions. Some sources have doubled their energy production in the few months since Webb first observed them, suggesting they are either tapping into increasingly powerful mechanisms or building towards some unknown objective. The energy emissions also exhibit modulation patterns that are more akin to communication signals than to random astrophysical noise. Frequency analysis has revealed structured information content, seemingly encoding complex data streams by using energy fluctuations as a carrier. Most mysteriously, these energy sources appear to be responsive to astronomical events happening elsewhere in the galaxy. When a supernova explodes or a black hole experiences an accretion event, the enigmatic power sources adjust their outputs in coordinated patterns, suggesting a real-time awareness of cosmic events. Webb has observed energy sources that seem to be linked in networks that span thousands of light-years. When one source alters its output characteristics, others respond with synchronized changes that happen far too quickly for light-speed communication to be the coordinating factor. The mechanisms for this energy production seem to operate through interactions with exotic states of matter that exist outside of normal space-time. Gravitational wave detectors have registered subtle distortions around these energy sources, which suggests they are drawing power from higher dimensional regions. Some sources of energy in the cosmos present a profound temporal puzzle. Their power generation seems to increase in advance of the very events that should be causing it. It is as if these sources can somehow anticipate future demands on energy and scale up their production before that need actually arises. This suggests they possess some form of access to information about cosmic events that have not yet happened. The emissions from these sources also exhibit properties of quantum coherence, a state that should be physically impossible to sustain across the immense distances they cover. What is particularly striking is that individual photons originating from separate sources show signs of entanglement. This indicates they share a unified quantum state, despite being separated by the breadth of a galaxy. Perhaps the most unsettling discovery is that these energy sources do not appear to be natural phenomena at all, but rather artificial constructs. The extraordinary precision of their output, along with their synchronized behavior as a vast network, points toward a technology operating on a scale that utterly dwarfs human engineering. It seems these installations are preparing for a future cosmic event, one requiring colossal power reserves stationed strategically throughout the galaxy. Their escalating power levels and increasingly coordinated actions suggest they are building towards some unknown objective on a galactic timescale. The implications of this are staggering, challenging our fundamental understanding of energy itself. It hints that the universe may harbor mechanisms for power generation that operate beyond the known laws of physics. But even these mysterious energy sources seem less significant when compared to the Webb telescope's discovery of matter that behaves as if it were conscious. Far away in the Perseus galaxy cluster, some 300 million light-years from Earth, ordinary material is self-organizing into patterns more reminiscent of biological life than of typical astrophysical processes. Clouds of gas that stretch for millions of light-years are forming into structures that show the hallmarks of living tissue. These immense cosmic formations have organized layers and what appear to be internal circulatory systems. They even demonstrate response behaviors, suggesting a form of awareness on a scale that dwarfs any planetary ecosystem. The flows of this matter create intricate networks that bear a striking resemblance to neural pathways, linking disparate regions of the entire galaxy cluster. Streams of material are seen transporting energy and information between distant galaxies. They travel through structured channels that hold their shape over millions of years. The efficiency of these cosmic circulatory systems is comparable to that of biological nervous systems. Dr. Jennifer Walsh of the Astrobiology Institute has dedicated her research to these organized matter behaviors. Her analysis indicates that the gas clouds react to external stimuli in a manner that implies an ability to process information. When these structures are struck by cosmic ray bursts or passing gravitational waves, they generate organized responses that then ripple through the entire network. The Webb telescope detected something even more profound about these living matter systems. They seem to be capable of reproduction through a process that looks much like cellular division. Very large structures have been observed splitting into smaller, independent copies. These new formations retain the complex organizational traits of their parent systems. The cosmic offspring then begin to grow, developing their own internal complexity over millions of years. The matter networks also exhibit adaptive behaviors, which points to an ability to learn. When subjected to repeated gravitational disturbances, for instance, the structures will actually alter their own configurations. This modification makes them more resilient to similar disruptions in the future. It is as if each cosmic event serves as a lesson, teaching the systems how to organize themselves more effectively. Most mysteriously of all, this organized matter displays signs of collective decision-making. When several different pathways are available for matter to flow between galaxies, the cosmic networks consistently select the routes that optimize the transfer of information and the distribution of energy. Such choices imply a capacity for planning, one that would require an awareness of conditions across the entire network. Webb has also observed these matter structures seemingly communicating with similar systems in other galaxy clusters. Organized pulses of energy travel between these distant networks. They move through a mechanism that appears to operate faster than the speed of light should permit. These cosmic conversations suggest a level of coordination between living matter systems across billions of light years. The biological behaviors of this matter go beyond simple organization, extending into complex, ecosystem-like interactions. Different kinds of matter structures have been seen in symbiotic relationships, where each type derives a benefit from its association with the others. Cosmic parasitism also seems to occur, with some matter systems actively consuming others to fuel their own expansion and reproduction. Certain matter networks even display defensive behaviors when threatened by phenomena like black holes or nearby stellar explosions. The structures will reorganize to shield their most critical information processing nodes, often sacrificing less important peripheral regions in the process. These survival strategies suggest sophisticated self-preservation instincts at work on a galactic scale. These living systems also show evidence of memory. They appear to maintain records of past events, which are encoded directly into their physical configurations. This allows historical information about cosmic collisions, supernova events, and galactic evolution to remain accessible within the network's architecture for billions of years. A deeply perplexing finding is that these matter systems seem to be evolving toward greater complexity and intelligence over cosmic time. Newer structures demonstrate more sophisticated organization and quicker response times than older ones. This suggests a directed evolution toward enhanced cognitive abilities. The organized matter appears to be working toward a collective purpose, one that necessitates coordination among multiple galaxy clusters. Their network behaviors indicate they are preparing for future cosmic events that will demand unprecedented levels of material organization and information processing. The implications here suggest that consciousness and intelligence might not be rare accidents of biology, but rather fundamental properties of matter itself. Yet even the mystery of living matter is overshadowed by Webb's discovery of gravitational anomalies in what was thought to be empty space. Within the cosmic voids that lie between superclusters of galaxies, there are regions with no visible matter that are bending light and warping space-time. They behave precisely as if massive objects were present. These gravitational anomalies are found in areas that deep space surveys have confirmed contain no stars, no galaxies, no black holes, nor any other kind of detectable matter. Despite this emptiness, space in these regions curves as though invisible masses, equivalent to billions of our Sun, were creating deep gravitational wells. These wells are powerful enough to trap light and alter the paths of passing cosmic rays. The gravitational effects observed do not match any of the patterns that would be expected from concentrations of dark matter. The gravitational warping around these phenomena is not the gentle expected curvature caused by dark matter halos. Instead, the distortions are intricate and geometric, hinting at a structure born of intention rather than the chaotic result of gravitational collapse. Throughout the vast emptiness between galaxies, Dr. Robert Kim of the Gravitational Physics Institute has been meticulously charting the locations of these seemingly impossible sources of gravity. His research has uncovered a remarkable fact. These anomalies are not isolated but maintain exact geometric alignments with one another, even when separated by hundreds of millions of light years. What emerges from the data is a picture of organized networks of gravitational influence, a stark contrast to the random scattering one would expect. Webb telescope observations, however, revealed something even more perplexing about the gravitational effects emanating from these voids. The fields are not static, they oscillate in synchronized patterns, a behavior that points toward active regulation instead of the passive presence of unseen matter. Their gravitational intensity ebbs and flows over time, following specific mathematical sequences that have no parallel in any known astrophysical phenomenon. These anomalies also produce a peculiar form of gravitational lensing, magnifying the light from certain distant objects while completely disregarding others nearby. Such selective amplification implies an ability to differentiate between various forms of electromagnetic radiation, seemingly choosing which cosmic signals to make more prominent. Perhaps the most enigmatic quality is how these gravitational fields appear to foresee the trajectories of objects passing through them. Beams of light and cosmic rays are observed undergoing slight course adjustments, gently nudged toward particular destinations, almost as if the fields were offering a form of navigational guidance for travelers between the stars. From these same empty regions, Webb has detected gravitational waves that are unlike the simple ripples from cosmic collisions. Instead, they carry distinct, structured patterns of information. The signatures within these waves exhibit features of modulation, a complexity more aligned with deliberate communication than with any natural gravitational event. The anomalies also produce temporal distortions that appear to contradict the established principles of relativity. Measurements of time dilation in their vicinity reveal fluctuations far greater than what their observed gravitational pull should be able to create. In some zones, time seems to speed up, while in others it slows down, effectively weaving together a network of temporal pathways that link disparate points in the cosmos. The sustained power of these gravitational fields points to an energy source that may operate beyond the confines of our familiar space-time. With no visible matter to account for their persistence, a compelling possibility is that they draw upon some form of exotic energy from higher dimensions. An even more curious detail is that these gravitational effects in empty space seem to react to major cosmic events happening far across the universe. Following a massive celestial collision, for instance, the configurations of these anomalous fields will shift in ways that suggest a direct awareness of and response to that faraway occurrence. What is perhaps most unsettling is the finding that these gravitational anomalies are not static, but are growing in both number and intensity over time. New sources of these effects are emerging in areas of space that were previously unremarkable. Simultaneously, existing anomalies are becoming more potent, and their behaviors more intricate, giving the impression that these gravitational networks are actively building a kind of infrastructure that stretches across intergalactic voids. The highly coordinated patterns of these fields hint at the construction of a transportation system, one that could potentially enable travel faster than light by creating controlled gravitational corridors. The implications of this are profound, calling into question our most basic understanding of gravity and suggesting it can exist apart from matter, governed by principles that may lie beyond Einstein's theory of general relativity. Yet even these gravitational enigmas seem minor when compared to Webb's most startling discovery of all: signals that appear to originate from outside our own observable universe.